Alright, welcome back guys. I hope you guys had a very nice Christmas and the last couple of few days. And yeah, I hope you guys are doing alright, and we're back with our little tutorial. Now, before I show you this, I do want to give you a bit of a teaser for what I am working on. Now, this is just very rudimentary stuff, but I did finally decide to go around and maybe make some sort of a shop for the Crazy Cabbie. Not only for my own app but also for you guys, because a lot of people were telling me about it, asking me about it. So as I said in my last video as well, it's going to be a fairly rudimentary one, and at the moment none of this really is wired up, but this was just to make a quick and scrappy proof of concept of how I want pretty much my shop to be looking. So this is how it looks like. For example, if you own this car, as you can see, it's unlocked already. And of course this will happen programmatically, but just to show you guys, for example, if you do not own the car, then the buy button would come on, and let's pick another car which we don't own, so to speak. And if I hit play now, then it would look something like this. So it would show you the number of gems or pickups that are required to purchase this car. It's gonna over here. It's gonna show you your lifetime gems. Now, this isn't something that we did in the Crazy Cabbie tutorial, but it's very simple. Once again, we'll be using player prefs. Now, I want to emphasize we will be using player prefs, at least for now. And as I said, this is just for a quick and scrappy way of doing a shop. So yeah, I just wanted to show you guys and let you guys know that the shop is something which is in the pipeline, and I'll keep you guys updated with how this goes. Alright, so back to our project. Okay, so in this video I want to talk about setting up some simple AI for our enemy character. So I'm going to go ahead and name him enemy. So we're going to have similar things going on for our enemy. Our enemy is going to be a NavMesh agent as well, so I'm going to go ahead and attach a NavMesh agent onto our enemy. I'm going to make him give him a speed of 1 for now, and I think this looks fine. We have our animator, and let me just quickly make sure if there's something that I am missing. Okay, so my Unity is doing alright. So this is my own personal project, by the way. So alright, yeah, okay. So once we've got our NavMesh agent, we can start writing our scripts. Now, once again, what I'm going to do is I'm going to throw in the script, and I'll explain my way through it. All right, so don't freak out. So this is the script. So go ahead and in your scripts folder, we can create a new C# script, and we'll call it enemy script. And once again, this is going to take it's going to take a while. So yeah, go ahead and open up your enemy script. In the meantime, I'll go ahead and copy the old one. All right. All right, so I'm going to go ahead and throw in the enemy script, and I'll walk you through it. All right. Okay, so first of all, in order for our enemy to move, so let's get rid of this, and yeah. Okay, so in order for our enemy to move, our enemy now has a NavMesh agent attached to it, right? So we can even fix the size of this a little bit while we're here. So let's reduce the height. As you can see, my laptop is acting a little bit funny. Yeah, so we can make the height a little bit more reasonable, and let's just leave the radius for how it is right now. Maybe make it a little bit smaller. Yeah. Okay, so in order for our NavMesh agent to move, we obviously need access to our NavMesh agent. So the first variable, private NavMesh agent, we can easily get this in our start by doing get component, and this is something we've done multiple times. The second thing we need is we need a target that is where we want our enemy to basically go. So in this case, our target for our enemy is going to be our player character. So once again, we have a private transform target. I could have made this public and drag and drop my player into it, but just for the sake of, you know, good practice, we've got a private variable and we can easily get the target like so. So we can do target equals game object dot find game object with tag player. So notice over here on my player, in the last video, we tagged it as player, so don't forget to do that, otherwise it's not going to work. So game object dot find game object with tag player will look for we'll cycle through all of these game objects and we'll look for a game object with the tag player, return that, and dot transform will simply return the transform. Because we don't need the entire game object, that is the player, along with all of its scripts and stuff. We just need the transform so that we know its location, because we want the enemy to pretty much go to it. Now, if you're a smart cookie, you've probably already guessed it. You're thinking, well, wait a second, the NavMesh agent has something called agent.setDestination, and I can simply do it like that, target.position, and that works wonderfully as well. So that's basically the crux of what we're going to be doing. Of course, there is some other code here which I will explain why I'm doing that. But if I were to, let's say, just to show you, if I were to comment all of that out, and if I were to just go over here and simply write that single line of code, we would have a working AI, so to speak. Now, of course, there is a method here, but let's ignore that for a second. We're not going to be calling it. So if I go back now, and if I attach the script onto my enemy, let's see what happens. So enemy script, and let's see if it's going to just let me play it without attaching all of those things. Alright, so notice how it's immediately coming towards me. Alright, so with just that one single line of code, and I made the enemy slower than myself so I could outrun him. And let's try and see what happens if I stop now. He'll come closer and he starts pushing me away. Alright, so we don't want that, so we can change that as well. The way we're going to change that is if you go to your NavMesh agent, there's something called a priority, and we can give our player a lower priority, which means that we can push it around, but not the other way around. So let's just check and see if this is working. So notice he comes in closer, and now he's no longer pushing us, but we can push it out of the way if we choose to do so. Alright. So it seems to be working just fine, right? And you're probably wondering, well, hey, what is all of this code? Well, the issue is over here, since simply by looking at the nature of our enemy, we can't really tell which direction he's looking in. But when he's going to be attacking us, then it'll be pretty obvious the direction in which he was looking at. And at the moment, he's just kind of coming towards us, but he's not really. But we also want him to be pretty much looking at us and attacking us when he is near us. Okay, we don't want him to be near us but attacking in the opposite direction and such. So we do need to take care of the direction in which this character is pointing. Now, of course, if our enemy was a humanoid, like with a face and everything, and if he was looking in the opposite direction but coming towards us, well, we'd be able to tell. But over here, that's exactly what's happening, but we can't really tell because of it's a little bit hard to tell in which direction this character is looking right now. So what we need to do is we need to make sure that while he's coming towards us, he's also looking at us. The direction in which he's looking is well towards us, the player. And if the player moves, then the direction in which the enemy is looking should also move. So his orientation is basically something that we need to fix. Okay. So I'm going to go ahead and remove this line of code, and I'll uncomment the rest of it. Alright, so first of all, in my update, I'm checking if target.gameObject.active in hierarchy. Now, the reason why I'm doing that is because at a later point in time, what I'm going to be doing is when the player dies, I deactivate him, okay? So I come over here and I pretty much go like so, okay? Programmatically, of course. So when the enemy eats him up, and as you saw in the preview, we're going to be deactivating the player. So once the player is deactivated, I don't want I don't want the software, or I don't want the script to throw some sort of a, I don't want it to throw some sort of a an error saying that it's still looking for a target, because like I said, this little line of code later on, it's going to be looking for a target, but the target won't be there, and that's going to end up giving us an error. So to prevent that from happening, I have this little if statement here. So only do the following things, that is, only go to the player, only try to look towards him and walk towards him and attack him if he is active in the hierarchy. Okay, so that's all I'm doing over here. If the player is alive, so to speak, if he's there in the hierarchy, then do the rest of the code. Okay, so that's what I am doing over here. Just a second. Okay, so this line of code, you guys already know what it's doing. It's setting the agent's destination to our target. Let's look at this is where I'm taking care of the rotations. Okay, so let's have a look. Taking care of rotations. Okay, so the first thing I need to do is I need to know the direction in which my player needs to look. Okay, what I'm trying to say is while, oh shoot, okay, so while my player is going around like so, basically my transform, my position is changing all the time, and therefore the direction in which this enemy object needs to be looking also needs to be changing. So first of all, I need a direction in which the enemy needs to be looking. The way we find direction is something like so. You can simply subtract the target dot position minus the transform dot position. So you're simply subtracting the two positions, right? I even pulled something up like over here by the Unity documentations, if this is not already apparent to you. So we've been doing this since grade school, and for those of you who are still in grade school, let me just tell you, if you want the direction between two vectors, then you just subtract them. So that's what's going on over here. I'm subtracting an XYZ position with another XYZ position, and now I'm getting a direction pointing from one to the other. Once again, you can also look over here in the Unity documentation how to gets a vector that's a point from player's position to the target. So it's doing the same thing over here like so. So to get the direction between our target and our current position, that is our enemy's position, we simply subtract the two. Now, since the movement and as far as the direction dealing is concerned, since we're only talking about the X and Z plane, since we're not doing any jumping or flying at the moment, then I'm automatically setting the direction.y to 0. Now, even if I was jumping, I would still probably set it to 0 because, I mean, unless if I want my enemy to be kind of maybe looking up while I'm in the air, jumping and such. So this doesn't really matter so much, but I was setting it as a precaution to 0. Now we have a direction in which we need to look at. Now the first thing that I want to check is the direction equal to 0? So just in case, if my target dot position minus transform dot position, if this somehow ends up giving me something like 0, 0, 0, which is vector 3.0, then I just want to set the direction as transform.forward. So it's just taking the transform of our enemy or this game object onto which the script is attached and just setting that direction in the forward direction of that enemy. So once again, this is just precautionary. I'm just checking to make sure that the direction is not 0, because if it is 0, then we don't need to do anything really. Okay, so what about in cases in which direction is not equal to 0? So now we're going to see some stuff which is not going to maybe make sense, but don't worry, I'm going to explain it. We have something called a target rotation of type quaternion, and we have quaternion.look rotation, and we pass in that direction, okay? And then we do something like transform.rotation. So this is familiar to us because this is just our transform, and dot rotation is something like over here. So when I go on my enemy, this is the transform, and transform.rotation gives us X, Y, and Z. So we are kind of hitting the nail somewhere. I mean, even if this looks a bit scary, you probably know that, oh, I'm trying to do something here with the rotation of my enemy. And then we have, once again, some gibberish, quaternion.slurp, and then blah, 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 blah. So what am I trying to do here? First of all, let's kind of talk about what a quaternion is. So I think I still have the documentation open here somewhere. Okay, so quaternion. Now, this is a really vague way of, describing what a quaternion is, but quaternion are used to represent rotations, and they are compact, blah, blah, blah. It doesn't really make sense, but the only take-home message I want you to take from this little page here is that quaternion are something which Unity uses to represent rotations, okay? So why are we using rotations here? Well, why are we using a quaternion here? Because we're dealing with rotations, okay? So what exactly are we trying to do? Let me try to explain. Quaternion is some sort of a rotation, and we want to go from a specific rotation to this new rotation, okay? So our character over here has a certain rotation, okay? So when I hit play here, this is going to change. Okay, so it has a certain rotation, okay? Now I want his rotation to change along with, my rotation. Depending on where I am, I want the enemy's rotation to be changing. So what I want to do is I want to change from my rotation, that is my current rotation, to a new rotation, which is where the enemy needs to be looking. So in order to do that, we introduce something called a target rotation, and we do something like quaternion.lookRotation.direction. What does this do? All right, so if I go back to my documentation here, again, if I look at quaternion.lookRotation, right? You notice that in the description it says that it's creating a rotation with the specified blah 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 blah. So we have a direction, okay? We have the direction in which our player needs to be looking, and this is happening in the update, so this is getting updated every single frame. We know the direction in which our player needs to go, but in order to go from direction, we need to find a way to go from this vector3 direction to something like the transform.rotation, okay? We need to go from having this vector3, that is the direction in which we need to be looking at, and we need to somehow reflect this over here in our rotation, okay? And the way we can do that is by using quaternions. This single line of code, basically, what that does is it creates a target rotation using the vector3, and quaternion.lookRotation simply creates a target rotation of type quaternion, which has the information for that rotation, okay? So we are at once again, I'm going to repeat this. We are at a particular rotation, and we need to get to a new rotation, okay? And we just saw in the documentation as well that Unity uses quaternions for rotations. So we're going to be using a quaternion type, and we just call the target rotation because this is the rotation that we want to get to, okay? And we saved that information using this direction, okay? So we had the vector3 direction. By this line of code, we were able to change that direction into a rotation, okay? I hope that makes sense. We only knew the direction up until now, but now we also know the rotation. Once we know the target rotation, we need to find a way to go from our current rotation to the target rotation. So current rotation to target rotation. And the way you do that is, again, another buzzword, quaternion.slurp. So slurp stands for spherically interpolate, is that right? So let's have a look. Quaternion.slurp spherically interpolates between A and B by T. So what does that mean, spherically interpolates? It means that it goes from point A to point B in time t in a spherical manner, okay? So over here, going back to our script, what we're doing is transform.rotation just gives me access to my transform. So transform.rotation gives me access to this because this is the part that we X and Y and Z rotation are the ones that we need to change now. And in quaternion.slurp, I want to, the first one is the current rotation, so transform.rotation. Then this is point A. Then point B is the target rotation. So we have the information now in this quaternion. We already have that information. So this is a rotation, right? Transform.rotation. And target rotation is also a rotation. And we want to go from A to B in a certain amount of time. And this is just, once again, a smoothing factor. This is something we've seen over and over again. Whether it's in our Crazy Cabby tutorial or any sort of a movement for our player, this is just a smoothing factor. So feel free to fool around with this. This is not like some key number 10, right? I just put it in there because it seemed to be smooth enough for the movement. So all of this here, this little piece of code, you could take this out into a function, and you can use this in pretty much any single instance or scenario where you need something to be looking at something else. Okay, so that's all that's going on over here. This little piece of code just basically makes the game object onto which this script is attached look in the direction of a target. Okay, that's all we're doing here, and I hope that makes sense. Then comes that little line of code here, which said agent.setDestination target.position. So this is the line of code which actually moves the player. Okay, so this sets the target and moves the enemy. Okay, so this line of code, that's all it does. Agent.setDestination, and for its destination we pass the target.position, so it starts going in that particular direction. Now the last thing I want to do is I want to check, well, is he close enough? And if he's close enough, then I want to attack. So the way I can do that is another if statement, and if agent.remaining distance. So you know how we're always setting the destination. So inside our NavMesh agent, there's something called the remaining distance with respect to the latest target that we've given it, the latest destination that we've given it. So if I stop moving and if I stand still, then, and we're not, giving it a new destination, then our player will keep getting closer. Therefore, the agent.remaining distance will, keep decreasing. So what I'm checking is the agent.remaining distance, so the remaining distance that the agent still has to go, if it is less than the stopping distance. Okay, now the stopping distance is something over here. If I go on my enemy, and I've got my stopping distance. Okay, this is the distance before it stops. Now at the moment it's set to 0. I don't want it to be set to 0 because I don't want it to get up all on top of my player. I just want him to maybe get close enough. So I'm just going to make sure what I did in the last one. So stopping distance was 1 and that one is as well. So yeah, I want him to stop a little bit before and not completely get on top of my player. And again, this is something which you will tweak depending on your game and your characters. Different enemies will have a different stopping distance depending on their shape and their attack range. And one worked fine. So going back to our script, I'm checking, is the remaining distance less than the stopping distance, which in this case is 1. And if that is the case, that means he is close enough, and now I can play the attack animation. Now, in order to play the attack animation, we need to have a look at our enemy's animator. Okay, so I'm going to go here, and I'm going to go in my animator, and we don't have one, so let's create one. I think we had a folder for this, so let me just see. Alright, so where we had a controllers folder, and here I will create another animator controller and enemy controller. So let's drag and drop that onto our enemy. And let's double click to open it up, and let me make sure it's here. Alright, okay. So let's look for our enemy animations. So what we want is we want a walk animation. So if I just drag and drop this in, it will automatically play the walk animation, which is fine because as soon as the game starts, our enemy starts chasing us anyways. Once again, I just want to check and make sure that all of my animations are set to generic. If I hit play now, I think I might get an error, but just ignore the error that I was getting just here. And notice how it seems to be moving. And this is what I was talking about. Like, you notice how it seems to actually be looking at, be at the right rotation as well, not just following me. So, anyways, going back to that animator, in this case, what I want to do is, instead of maybe using a boolean, I want to use a trigger, and I'll tell you what a trigger is. Is attacking. Okay, I guess that's the one that I was using. Let me just make sure. Okay, so the name of my trigger was attack, so I'll just keep it the same. Okay, so what I do is, let's have our attack animation here, like so, okay? And the thing is, I will leave my attack animation floating like so. There's not going to be any back and forth, but what I'll do is I'll make it, oh, not that. Okay, so I'll set this one as default. I'll make a wow, I keep doing that. I'll make a transition from my attack to my walk, okay? And over here on my condition, I will just have my trigger attack. So this is what happens. When the game begins, it will automatically start looping the walk animation for the enemy. But as soon as something through code triggers this attack, then it will, from anywhere and you know, whatever it's doing, it's going to stop and it's going to play the attack animation one time, and then it will go ahead and play the walk animation. So let me just make sure one more time, and it looks fine. I just want to go ahead and make this transition as well. So from any state, it can go into attack, and from attack, it will go into walk. Okay, and yeah, so I pretty much messed that up. So what we want is from any state, we want to go into attack, right? So this here should be the condition, and this condition should not be there, okay? So I'm going to go ahead and remove this transition, and I'm going to make a new transition, okay? So I hope that makes sense. What I'm trying to do is we set up a trigger, okay? And a trigger is just like, you know, a trigger, like pressing the trigger of a gun. So as soon as I want to attack, I'm gonna press that trigger. And it's gonna play that attack animation from any state. And once it's played that animation, it will then go ahead and go back to the walk animation. Okay. So the way we can do that through code is, let's have a look. If he is close enough, then we need to attack, and I can do this by doing anim.setTriggerAttack. Okay. So I hope that makes sense. We just check, is the agent close enough? And if it is, then we want to play the attack animation, and we're doing this through a trigger. Now, while I'm here, I'm going to go ahead and, just to avoid some warnings, I'm going to go ahead and comment out some of this stuff, which we will look at in a later video. Okay. And I will also comment out all of this stuff. Alright, so I think everything is good to go now, and if I hit play, which one was it? Yeah, so this is the one that we are looking at. I'm going to go ahead and clear all these warning and errors. Let's try to hit play and see what happens. Okay, so it's following me, which seems to be fine, and if he gets close enough, he should start. Alright, so as you can see, it looks a bit funny. And notice how the stopping distance is perfect, so it actually looks like it's hitting me. It's quite close. And if I go back to my animator, you'll notice that since I'm over here, it's constantly checking in the update, is the agent.remaining distance less than the stopping distance? It's returning yes, and therefore it's triggering the attack animation. Now if I go back and if I move away, then he will go back to his walk animation. If I go over here and look now, notice how it's walk, and when he gets close enough, it will start playing the attack animation. So I hope that makes sense. This has been a nice little review for the Unity's animation system. So I think that's all for this video. Yeah, that's all I want to say. So once again, if this was helpful, if you liked what you saw, then don't forget to subscribe to stay tuned, and feel free to drop a comment if you have any questions. And yeah, I hope to see you in the next video. Thank you very much.